Geometry, lesson 57, finding perimeter and area with coordinates. So we're just going to jump right in this. The area of the figure just depends on what the shape is. So example 1, it says, find the perimeter of the rectangle with coordinates A, B, C, and D, and it tells us what they are. So the first thing you're going to do to graph this is graph these on the coordinate plane. So we have A is 2, 4. I'm going to use a marker. 2, 1, 2, 3, 4. B is 2, negative 2. C is 3, negative 2. And D is 3, 4. So we can connect the dots, and it looks like we have a rectangle. And that's what it said that we have. So to find the perimeter, we need to figure out from A to D how far it is, and from A to B how far it is. So you can count, or there is another way you can figure it out. I'm going to show you how to do it by counting. So starting at A is 1, 2, 3, 4, 5, 6. And then from A to D, right here, we're on 2, and this is on 3. It's just 1. And the sides are the same. So you can do it by counting. You can figure out the distance between them. Another way is we have the distance formula, which I'm going to show you. To find the distance, this means to find the distance between point A and point B. It's the absolute value of y1 minus y2. y1 is 4 minus y2, which is negative 2. The absolute value of 4, this is going to be plus because we have 2 negatives. Absolute value of 6, which is 6. We found that. You can do the same thing to find the distance between A and D, but we already figured that out. So you can use either way, the distance formula or counting them. Counting them will work when it's really easy, but the distance formula works especially if you have one at like 5.5 or 5.25, when the numbers aren't as easy to jump from one line to the next. So we know the length of AB, the length of DC is also going to be 6, and the length of BC is also going to be 1, since it's a rectangle. To find the perimeter, you just add all of the sides together. 6 plus 1 plus 6 plus 1. Which the perimeter is 14. Next, my marker bled through on this one, sorry. It says on example 2, find the perimeter of rectangle EFGH with these coordinates and give your answer in simplified radical form. So the first thing we want to do is we want to graph it. E is 1, 3. I'm going to use my marker again. F is 2, 0. G is negative 4, negative 2. And H is negative 5, 1. Okay. Connect the dots. And we're going to use the distance formula to figure out the length of each side. Okay, so the distance, let's do the distance between EF, the short side. Okay, so the distance formula, let me do a pen, I'm not sure if you can see this. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to find the distance of, and I'm going to write a little sub of EF. We want to find the distance between these 2 points. So x sub 2, so f, x is 2, the x for E is 1, the y for f is 0, the y for E is 3. So let's simplify this. The square root of 2 minus 1 is 1, so it's going to be 1 squared, and 0 minus 3 is negative 3 squared. The square root of 1 plus 9, 1, is 10. The square root of 10, which is not a perfect square. Okay, I'm going to write that over here. It's the square root of 10. Now we want to find the distance from F to G, and we'll use the distance formula again. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. We're doing from F to G. So our second x, or G, is negative 4 minus, the x for the x for F is 2 plus y2, so the y for G is negative 2 minus the y coordinate for F, point F. So simplify this, you get the square root of negative 4 minus 2 is going to be negative 6 squared. Negative 2 minus 0 is going to be negative 2 squared. 6, or negative 6 squared, is 36 plus 4. The square root of 40. That's the distance from F to G. Now, we want to write this so that we're able, because they're asking us to find the perimeter, we want these radicals to be in the same form. This is the square root of 10, this is the square root of 40, so we're going to simplify it a little bit, rewrite this, rewrite the square root of 40. Find out, are there any factors of 40 that can be squared? So use your factor tree, that always helps. Let's divide by 2, we get 20. If we divide by 2, we get 10. So the square root of 40, another way to rewrite it is 2 times 2 times 10. I'm not going to factor anymore because if we factored 10, it'd be 2 times 5, and we don't need that. We want them to both be the square root of 10. So 2 squared, or 4 times 10, is 40. We know the square root of 4 is 2, and we're going to leave the square root of 10. So the distance from F to G is 2 times the square root of 10, and we're leaving it that way so that these guys are the same and they are congruent. Now that we know that, we can add our perimeter, or find the perimeter. The distance from H to E is going to be the same as the distance from G to F, 2 square root of 10. The distance from H to G is going to be the same as E to F. It's going to be the square root of 10. So to find the perimeter, you just add all the sides together. 2 square root of 10 plus square root of 10 plus 2 square root of 10 plus square root of 10. You can add everything together because everything underneath our radical sign is the same. The stuff under the radical is going to stay the same. You just add the numbers in front of the radical. 2 plus 1 plus 2 plus 1. That is 6. 6 times the square root of 10 is our perimeter. Now let's look at our next example. Calculating area with coordinates. We need to find the area of the right triangle ABC with right angle BAC. So here it's graphed for us. We can find the coordinates pretty simply, but we do know that the right angle is angle BAC. So this right here is our right angle. And we're looking for the area. So first we're going to have to find the length of the sides using the distance formula, and then we'll use our area formula for a right triangle is 1/2 the base times the height. So let's use the distance formula. First, let's figure out where these are. It's at A is at 1, 3. B is at -1, 2. And C is at 3, -1. So that will help us find the distance. So let's use our distance formula. Find the distance from A to B. It's the square root of x2 minus x1. So x2 is -1, x1 is 1. And we square that, plus y2, which is 2, minus y1, which is 3. And then we can simplify this. -1 minus -1 is -2 squared, plus 2 minus 3 is -1 squared. 4 and 1. So 4 plus 1 is 5. We have the square root of 5. The distance from A to B is the square root of 5. We don't have a perfect square for 5, so we'll just leave it like that. The distance now that we're going to look for is from A to C. Square root of x2, which is 3, minus x1, plus y2, which is -1 minus 3. So that's 3 minus 1 is 2. -1 minus 3 is -4. So 2 squared is 4. 14, or -4 squared is 16. So 16 plus 4 is 20. But we want them to have the same number underneath the radical. So we're going to simplify this and use your factor tree if you need to. Divide by 2, we get 10. We want it to have 5 underneath there, and we need to take the square root of something so we can simplify it. So divide by 2 again. Look, we've got our 5. 2 times 2 times 5 is 20. So we have square root of 2 times the square root of 2 times the square root of 5. 2 times 2 is 4. We know that that is, we can take the square root of that. And the square root of 2, or 4 is 2. Square root of 5 stays the same. So now we know the distance from A to C. And we're going to use our area formula because they ask us to find the area. You don't have to worry about this distance right here because this is the base and this is the height right here. So using our area formula, 1/2 base times height. The base is the square root of 5. The height is 2 times the square root of 5. These 2's are going to cancel. You're going to be left with the square root of 5 times the square root of 5, or 5 times 5, since you can multiply. If they have the same number underneath the radical, or anything under the radical, you can multiply them. So we have the square root of 25, which we know what that is. It's a perfect square. Our area is 5. Now we're going to work on estimation. Sometimes you're going to have an irregular polygon or some irregular figure, and you're going to have to estimate the area. We have 2 of them. I'm just going to do the first one. It says estimate the area of this figure. Well, what you need to do is fill in all of the full squares that are inside your figure. 1, 2, 3, down here is 4, 5, 6, 7, 8, 9, and 10. We have 10 full squares. Now we know for the 10 full squares, that's going to be an area of 10. Next, you have to estimate the rest of the squares that aren't complete. If you look here, here, and here, and also here, these triangles, if you butt them up next to each other, they will make an awesome little, it's an identical right triangle. So these squares right here, 1, 2, 3, 1, 2, 3, it makes a great right triangle. And the area of a triangle is base times height. So this is the height and this is the base. 1 and 3. I'm trying to write where you can see it. This is also 1 and 3. If you were to put them together, then you're going to make identical right triangles. So they have an area of 3 square units, these 2 triangles, if you put them together. Next, this right here is also a triangle, and it looks like it's a right triangle. From here to here is 2. From here to here is 1. So it looks like base times height divided by 2. So the base is 1, the height is 2. If you divide that by 2, you get 1. So right here, we have 1 square unit. Here, it's base times height divided by 2. 1 times 3 is 3, divided by 2 is 1.5, but you get the same thing down here. So both of these together is going to make 3. We have 10 already done. Now these last ones, there's about 6 squares, but none of them are complete. So we need to figure out what they would be. We've got like this one right here, and this makes a little triangle right here. This is 1.5 and this is 1. It's about 1.5 and 1. So if you were to multiply the base, which is 1, and the height, which is 1.5, divide that by 2, and then we'll add all these together. So 1.5 divided by 2. And let's see, this is about half of a square. This is half of a square. It makes 1. And then this one right here, if you were to add them together, it also, if you were to put them together, it makes 1. These two. Okay, so we have 3 more right here. So we have 10 that we started with, 3 here, that makes it 13. 1 here is 14, 3 here is 17 total. Our square units, we don't really have a unit, it doesn't say feet or anything. We have 17 square units. That's our estimate for this polygon. Might be a little more, a little bit less, but that's our estimate. You can figure out how to do this one. Again, fill in the full squares and then figure out what the rest would be. It's an estimation. And I will let you know your homework for lesson 57 is practice problems A through D.